So now we have completed step 7 of the 11-step process, and step 8, next step, concerns many-to-many relations, and step 9 concerns multi-valued attributes. So if we look at our model, which one should we look at? If we look at this model, we see that we have completed all tables, all entities and all relations there are. If we look at this one, we see that we have still not handled the multi-valued attributes and their relations. But there is no many-to-many relation in any of the models. But we want to practice creating many-to-many relations, right? So I'm thinking to do like this. I will treat these, the multi-valued attributes, as many-to-many relations. In the Lucid chart model, which is also uploaded on the course web, I have treated one of them, email, as a many-to-many relation and phone as a multi-valued attribute. But in this model here, I'll treat both as many-to-many relations. That is, I will assume that it looks something like this, something like this, and we'll handle that. The reason I'm treating both as many-to-many relations here is that then I'll do one first and then I leave the other as an exercise for practicing, and we'll look at the result of that later. That means here there will be no handling of multi-valued attributes, and that's of course also bad. But it turns out that this thing here, visit purpose and its relation to visit, is in fact a multi-valued attribute. So I'll talk about that when we come to multi-valued attributes instead. So now let's change to this thing here. Okay, so first we will handle them as many-to-many relations, and then and create those. I will create one and you will create the other. Then I will talk a bit about differences between handling them that way and as multi-valued attributes. And then we're done with many-to-many relations, and we'll move to the next step, which is about multi-valued attributes. So back to how it was, like this, and move on to step number 8. Create a cross-reference table for each many-to-many relation. A cross-reference table, as you know, is a table that is used, that is a new table that is created to resolve a many-to-many relation. We do not want many rows, many identical rows. I mean, say, there's no way to place the foreign key, right, if we don't have a cross-reference table. If it looks just like this, then where to place the foreign key? We want both entities have many on the other side, so both will need a lot of foreign keys. So we can't just have a column for the foreign key. We would need rows for the foreign key, which would create a very strange unnormalized database. So we need to create a cross-reference table. Okay, for the many-to-many relation. So we create such a table. And in that table, we use the existing entity's primary keys as foreign key. So we will have two foreign keys in each cross-reference table, one for each of the primary keys. And the primary key of the cross-reference table is either the foreign keys combined, if we do not think I mean, that would be the default, to use the foreign keys combined, because then we regard the cross-reference table only as a helper thing to resolve the many-to-many association. But it could be that the fact that there is needed a cross-reference table shows us that we forgot some important entity in our models, that we have forgotten some important entity in the models. And then we realize that this new cross-reference table is really something that exists in the reality and that should have a proper identity of its own. And then it might be a good idea to create a surrogate primary key. Next step is to, as usual, consider foreign key constraints. And last, we consider adding more columns to the cross-reference table if we realize that this cross-reference table represents something that really exists in the reality and that should be modeled in the database, then it might be that this thing has more more attributes, and we need more columns. But that is only if the cross-reference table really symbolizes an existing entity, not if it is just a helper table to resolve the many-to-many relation. Right, so then we create the cross-reference table. Let's say that we first consider phone. So we create cross-reference table. Does it fit in here? Yeah. So we can call it, name it after the two tables. It is cross-referencing person. Which one were we talking about? Phone, I think. Person, phone. Okay. We should move this a bit to the right. Like that. Okay, so we created it. Then we use the primary keys of the reference tables as foreign keys. We have not assigned a primary key to phone, right? So should phone have, well, let's not think too much. We must at some point just finalize this model. Let's decide that the phone has a surrogate primary key. I don't know if it's completely meaningful. Maybe we could use the phone number as primary key. But okay, you can think about that. I'll just do like this to move forward, not to make the video too. It's already too long, but not to make it longer yet. Okay, right. The names here are not okay. That was the person. So that should be called person ID. And the other one should be called phone ID. Like that. Both are not null, that's fine. Both are int. So now we have, let's follow our guide. Use present primary keys as foreign keys. We have this thing here, which is the primary key. We use it as a foreign key. It's not null because it's mandatory on the other side. That's fine, right? And we have this thing here, which is the foreign key related to the person ID, not null. It is the foreign key, yes. Both are ints, yes. We created foreign keys. The primary key is either the foreign keys combined or a surrogate key. So now I used the foreign keys combined, and let's keep it like that. The person phone does not represent anything that really exists in reality. It's just a helper cross-reference table to resolve the many-to-many relation. So we keep it like that. Next, consider foreign key constraints. So again, the alternatives are prohibit, allow, and delete. And in this case, the cross-reference table is only a helper table. So we should use, so if we delete the person's phone numbers should disappear. And then also this thing, the cross-reference table should disappear. If we delete the phone number, then of course that phone number is not related to anything. So then we should also remove this entry here. Right, so both foreign keys have on delete cascade. Let's add a note that says this. There. And finally, consider adding more columns. But since we already decided that this is not this cross-reference table person phone does not represent anything that exists in reality. It is just a helper table to resolve the many-to-many relation. Therefore, there are no columns. Maybe it's better to say it the other way around. since we don't find any more data related to this, well, or any meaning of it, then it is not a real entity, but just a helper table. So that means we are done with all steps here. Yes. Anything more to say about this? Yeah, there was maybe one thing more we should consider: the cardinalities of these relations. Since both are not null, then both other ends must be mandatory. We cannot have any 0, 1 there. Okay, so the question, what we are considering, is the cardinality at the cross-reference table. Let's first consider this one. So right, there can be persons without phone number, therefore without such cross-reference entry in the cross-reference table. That's fine. But for the other end, there should never be a phone number without a person. So therefore, we cannot have 0 many here. We should have 1 many there. So let's change that. One or more, like that. Yes, now I think we are done. Okay, that's fine. So then pause the video and do the same for the relation between email and person. Right, so then let's have a look at this cross-reference table. So it is here. And as you can see, it's very similar to what we did before with the person-phone table, connecting the person and the phone. In fact, exactly the same reasoning applies here. So there is the person ID, which connects to which is a foreign key to the person table, and the email ID, which is a foreign key to the email table. And none of them should be null, because the only purpose of a row here is to connect a person and an email, and if one of them is null, it would not do that. So that's why both are not null here. Also, both have on delete cascade, because well, if a person is removed from the database, then that person's email addresses should not be kept. And if an email is removed, then there's no point in having an entry in the cross-reference table connecting nothing to a person. Okay, so that's this cross-reference table. Then we can have a look at step number 9, which is to handle multi-valued attributes. And we already created tables for those, but now we used cross-reference tables instead. But I will we'll have a look at multi-valued attributes anyway. So okay, what we have to do with tables representing multi-valued attributes is to create a foreign key and a primary key. So the foreign key is related to the table for which an entry in this table is a multi-valued attribute, and the primary key is the foreign key and the multi-valued attribute in combination. So here we, as I was just saying, we turned our multi-valued attributes into many-to-many associations and solved them with the cross-reference tables. But I have created another model here using Lucidchart, just to illustrate usage of Lucidchart also, and also to illustrate slightly different ways of modeling a few things. So okay, here's the phone, and here it is a multi-valued attribute. The email and the email and person was, as in the previous model in ASTA, a many-to-many association. But let's now look at the multi-valued attribute over here. So there are some differences. We can see that while email is unique, and also phone in the ASTA model is unique, here the phone is not unique. And why is that? That's because with a multi-valued attribute, we don't have a many-to-many association, but instead a one-to-many association. So a certain phone can only be associated to one person. But that means that if two persons have the same phone number, then there will be two different rows with the same phone number. And that way it cannot be unique. Okay, So the foreign key is, of course, the primary key of the table that has this multi-valued attributes, namely the person table. And the primary key is the multi-valued attribute and the foreign key combined. Why? Because none of them is unique in isolation. The phone number, as I just was explaining, can have duplicates. There can be multiple rows with the same phone number if many persons have the same phone. And there can also be multiple rows with the same person ID if the same person has multiple phone numbers. But there can not be multiple combinations. There's only one row explaining that this person has this phone number. So that's why we can use both of them in combination as primary key. Okay, that was the phone and email, but there's one more interesting thing here, because now that we consider multi-valued attributes, we in fact realize that the visit purpose is a multi-valued attribute of the visit, because this reasoning that I just made for the phone and the person exactly applies to the visit and visit purpose. One visit can have many purposes, and the visit purpose has no meaning on its own apart from being the reason of a visit. We have already decided that we don't store this general visit purposes like names of diseases or things like that, general reasons to see a doctor, but it's just free text that someone working at the healthcare establishment or the patient themselves type as they see when they see the doctor and book an appointment. So it's a multi-valued attribute of a visit. Again, we could start thinking, why multiple values? Why not just one? If it's all the text there, if the person type fever and headache, why type it as two attributes, two values instead of one? But let's not start that discussion again. Maybe it would have been better, but that must be discussed with the customer. And now we have agreed with the customer to model it like this. Okay, so the visit purpose is a multi-valued attribute of visit, and that reveals that there is a flaw in our model. The primary key of the table representing the multi-valued attribute is the foreign key and the multi-valued attribute combined. But here we only made the foreign key, turned the foreign key into primary key. But and that is not okay because it's not unique. There can be many rows in the visit purpose table with the same visit ID if one visit ID has multiple purposes. And because of that we cannot have only the visit ID as primary key. And that is what is explained here. And that is also what we looked at here when we looked at the phone as a multi-valued attribute. So the solution to this mistake is to also make the description into a primary key like that. Okay, now we have combined primary key there, and the visit purpose is appropriately modeled as a multi-valued attribute of visit. Okay, there are some more things that we could comment on here maybe. We could consider, for example, if should the phone and the email really have their IDs, couldn't we use the phone number and the email as primary keys, given that they are anyway unique? Okay, maybe that would be reasonable. We could argue that a phone and an email do not have meaning on their own. They're just there as something related to person. So yeah, it would maybe make sense to remove the surrogate keys from phone and email and use natural primary keys, phone number and email instead. Also, we could start once again the discussion whether we really should have multiple purposes for one visit and turn this into a one-to-one relation instead. And in that case, might be a good idea to join the description attribute into the visit. If there can only be one description for each visit, maybe we might as well add it as an attribute in the visit table. Okay, those are things to consider if we wish, but this lecture is already very long, so I'll just leave it like this for now. And that means that we are done with also the multi-valued attributes. Then we move on to step number 10, and that is to verify that the model is normalized. And we have reasoned about normalization while doing the model, while creating the model, so it should be normalized. There's no reason to first create an unnormalized database and then to normalize it. So, of course, so I think it should be okay, but let's check. So regarding first normal form, there are only atomic attributes now, right? We're taking care of all multi-valued attributes, and there were never any composite attributes. So that's fine. Regarding second normal form, there are only 3 tables which have composite primary keys, and they have no other fields, so second normal form is okay. And then for third normal form, there must be a table that has 2 fields besides the primary key, right? And that is these tables. Yes, and I don't think there's any transitive dependency anywhere here. What we maybe could claim is that, as was discussed before, that city is decided by zip, which in turn is decided by the person, or maybe via street if we wish, I don't know. Okay, so this, if we consider this to break the third normal form, then it would lead us to reintroduce the address table that we had at the beginning but later deleted. But I think this would be really exaggerated. We should not over normalize, and I think this is quite fine. It is not uncommon at all to store data like this, and I agree with that decision. So that means it is normalized. Very good. Then we move on to step number 11, which is the last step, and that is to verify that it is possible to perform all planned operations. And the planned operations were specified in the text that we read when we started to create the conceptual model. And there is only one planned operation, and that is what is highlighted here, that it shall be possible to see who has visited which doctor, when, for what reason, and at which healthcare establishment. So if we start with the person, that's the who, then following this relation we can find the visit, and when we've found the visit, we should see which doctor, when, why, and at which healthcare establishment. Which doctor, following this relation. When, it's here. Time, why, following this relation, and with which healthcare establishment, following this relation. So it's fine, all planned operations can be performed. And that means the last step is concluded and we are done. So this is our final model. Right, so I'll upload this model and also this Lucid chart model to the course web, and I'll also create an SQL script that creates this database.